When I first looked at the early reports on 3I Atlas, I expected another routine interstellar visitor, a faint, distant blur passing silently through our system. But the numbers in that first dataset didn't behave the way they should have, and that was the moment I realized something about this object was already out of place. 3I Atlas was discovered on July 1st, 2025 by the Atlas Survey Network in Hawaii. At that time, there was nothing unusual about its trajectory. It was simply classified as the third confirmed interstellar object in history, following Oumuamua in 2017 and Borisov in 2019. These objects are rare but not unexpected. Interstellar debris drifts through the galaxy all the time. What made this one different was not its arrival, but how cleanly the data aligned around its path. The object approached the Sun on a nearly perfect hyperbolic trajectory, the kind we associate with natural wanderers from beyond our system. But the more I examined the readings, the more a subtle tension grew beneath the surface. Most comets brighten as they approach the Sun. Their volatile ices turn to gas, surrounding the object in a halo of activity. Yet 3-eyed Atlas behaved with an unusual restraint. Its brightness curve rose, but not in the characteristic way a comet should. There were no early signs of significant outgassing, no expected turbulence in its photometric profile. Several analysts quietly noted the same thing. It seemed too stable for something nearing perihelion. That stability raised the first quiet question. What exactly was this object made of? When I looked deeper into the reflectivity data, I noticed something that even now feels difficult to explain. The albedo suggested a surface far denser and darker than typical cometary material. Not icy, not fragile, almost metallic. Some observers mentioned, off the record, that the polarization readings looked off, as if the surface scattered light in a way they'd never cataloged before. None of them wanted to put that in writing. Not yet. As the object drew closer to the Sun, the situation shifted from curiosity to concern. By early November, 3 Atlas was moving into a geometric alignment that placed it directly behind the Sun from Earth's point of view. For 3 weeks, every optical telescope on the planet would be blind to it. It was the worst possible moment for an observational blackout. Normally this wouldn't matter. A natural object follows gravity. It does not change course. But the timing troubled me. It wasn't just close to the Sun. It was perfectly hidden. The kind of alignment that blocks all direct observations is rare, and the fact that it occurred at the object's moment of closest approach was a statistical coincidence I struggled to ignore. Some colleagues argued I was overthinking it, yet the same night the object slipped behind the Sun, several radio observatories picked up a strange electromagnetic hiss, subtle, brief, and without clear origin. It wasn't a signal, not in any structured sense, but it was odd enough that the technicians scraped the logs twice to confirm it wasn't interference. To this day, the source remains officially undetermined. That uncertainty is what stayed with me. No one could explain why the photometric data looked incomplete, why the object's surface behaved differently than expected, or why several automated systems flagged anomalous reflectivity patterns in the final hours before the blackout. None of these findings were dramatic on their own. Together, though, they formed a quiet pattern, a pattern I couldn't shake. Now the object is fully behind the Sun. We cannot see it. We can only wait. Whether the next set of images will answer the unresolved questions or multiply them is something I cannot predict. All we know for certain is that when 3I Atlas reemerges, it will either behave exactly like a natural comet, or it won't. For now, the truth sits somewhere in that silence behind the Sun. And until the object comes back into view, all we can do is prepare for what the data may show next. When 3I Atlas disappeared behind the Sun, I thought the uncertainty would fade with time. Instead, the silence only sharpened the questions left hanging in the data. The object's stability, its unusual reflectivity, that faint electromagnetic hiss, all of it lingered like unresolved variables waiting for a solution. The truth is that our observational blackout didn't slow the investigation. If anything, it intensified it. With no new images available, the teams at JPL and the European Southern Observatory began dissecting every pre-blackout measurement line by line, and what they found in those early layers was the first indication that the familiar explanation might not be enough. One of the initial puzzles came from the object's approach path. When interstellar visitors enter our system, they normally arrive from random angles relative to the ecliptic plane. The galaxy is three-dimensional, chaotic, and indifferent to our geometry. But 3I Atlas slid into the solar system almost perfectly aligned with the ecliptic, deviating by only a few degrees. Statistically, that alignment should be rare, extremely rare. Some analysts calculated the odds at around 0.2%. Others placed it even lower. I tried to dismiss it as a coincidence. It's easy to overinterpret anomalies when the data feels incomplete. But then came the second pattern. In late July and early August, a faint plume of gas was recorded. Subtle, but real. At first glance, it looked like standard cometary activity. Comets vent material. They release jets as they heat up. The process is messy but expected. What wasn't expected was the direction. Solar radiation pushes dust and gas away from the sun, so any natural plume should flow outward, yet spectroscopy suggested the jet from 3I Atlas pointed toward the sun. At first I assumed it was an optical illusion, an anti-tail caused by our viewing angle, but the geometry didn't support that. The jet was physical, persistent, and oriented against the solar wind. No one wanted to call it what it resembled. Controlled thrust. I asked one of the European analysts whether she believed the reading was real. She paused, lowered her voice, and said only, "If it isn't an error, it changes everything." Then she asked me not to quote her. Around the same time, I noticed a second inconsistency. The object's size, roughly 5 kilometers across, placed it firmly in the mountain-class category of interstellar bodies, far larger than Oumuamua or Borisov. Yet its velocity was unusually high for an object of that mass entering the system. Formation models predict either small, fast particles or large, slow ones. But 3I Atlas was both large and fast, a combination that doesn't fit easily within natural parameters. A colleague ran a simulation suggesting that an external boost, long ago in its history, would explain the energy profile, but gravitational slingshots alone couldn't account for it. Something didn't add up. Still, none of these anomalies were enough to draw conclusions. Science demands restraint, and so I told myself what every rational observer tells themselves. Improbable does not mean impossible. But the pattern didn't stop there. The timing of the entire event began to look unnervingly precise. 3I Atlas passed near the orbital paths of several planets in what resembled a sequential tour. Mars, Venus, Jupiter, all within a narrow geometric corridor, traced with a precision that felt intentional, even if no one dared to say it out loud. And then there was the blackout. The object reached perihelion, its moment of closest approach to the sun, when the heat and radiation were strongest, at the exact time Earth's line of sight placed it completely behind the solar disk. No spacecraft could observe it. No telescope could track it. It was a moment of maximum physical stress and maximum observational blindness occurring simultaneously. I tried to find comfort in probability. Coincidences happen. But a series of them? Coincidences within coincidences? That's where the reasoning begins to fray. Some insiders started whispering about a pattern. Others suggested we were missing key context. A few, speaking strictly off record, admitted the sequence felt too elegant for a random object. That word, elegant, stayed with me. It described the geometry of the path, the timing of the blackout, and the consistency of the anomalies. Not dramatic, not sensational, just precise. Every time I revisited the numbers, I felt the same quiet pressure beneath the data. Not a conclusion, not even a hypothesis, just a sense that the object behaved as though following rules we hadn't fully identified. Now the blackout continues. For several more days, the object will remain hidden behind the sun's glare. We wait, patiently, methodically, for the moment it reappears. If it behaves exactly as the models predict, many of these questions will dissolve naturally, swallowed by the simplicity of gravitational motion. But if it doesn't, then the silence behind the sun may hold more than just the absence of light. It may hold the answer we aren't yet ready to face. For now, all we can do is trace the clues, hold the patterns in our mind, and wait for the first post-perihelion measurements to break through the radio noise. Because when 3I Atlas emerges again, the data will either calm the unease or amplify it. When the blackout entered its second week, I kept returning to the same question that Part 2 left unresolved. If all the anomalies were merely coincidence, why did they align so precisely? And why did each new layer of data seem to generate a deeper contradiction rather than resolve an existing one? While the world waited for the object to re-emerge, the work inside the laboratories intensified. The teams began unpacking a different data set, the one that described what 3I Atlas was made of, and this was where the story shifted from unusual to unsettling. Comets, by definition, are icy. They carry water, carbon dioxide, and frozen gases that sublimate as they near the sun. But the spectral analysis of 3I Atlas was almost entirely dry. Only a few percent of its mass resembled water ice. The rest indicated a dense, dark, and highly durable composition. When I first saw the numbers, I assumed it was an error in calibration. But cross-check after cross-check confirmed that the object lacked the most fundamental characteristic of a comet: its ice. What troubled me even more was the plume recorded before the blackout. The gas sample, faint though it was, didn't match typical cometary chemistry. Its nickel-to-iron ratio was inverted, far more nickel than iron. In nature, iron dominates. Nickel is present, but always lower, always secondary. Yet here, the balance was reversed, mirroring refined alloys used in high-temperature engineering. One of the analysts whispered the comparison before quickly adding, "But don't quote me on that." It wasn't that she believed the object was artificial, it was that the composition raised a possibility no one wanted to articulate. Then came the polarization data. The way 3I Atlas scattered light didn't match Oumuamua, Borisov, or any comet in recorded observation. It showed extreme negative polarization, an optical behavior associated with structured or coated surfaces. A material designed to absorb and redirect light more efficiently than anything naturally formed. Some astronomers suggested a porous, carbon-rich surface. Others quietly admitted those models fit poorly. All of it built the same silent tension. If this thing was natural, it was unlike any natural object we had ever seen. Still, we waited. Science requires patience, even when the evidence feels like it's leaning towards something extraordinary. And the blackout gave us time, too much time, to analyze the final anomaly that emerged just hours before. 3I Atlas vanished from optical view. That anomaly was its timing. Its trajectory had carried it on a path that performed what looked almost like a planetary survey. Mars, Venus, Jupiter, each encountered at geometrically clean distances arranged in a sequence that resembled a grand tour. The word coincidence was repeated so often in internal meetings that it lost meaning. Statistically possible? Yes. Statistically comfortable? No. And at the center of this choreography was the perihelion itself, the exact moment when the sun would hide the object from Earth's view. A perfect curtain of blindness, a blackout lasting nearly 3 weeks, overlapping precisely with the moment when the object would undergo its greatest stress, its greatest heat, and possibly its greatest change. As the third week approached, no one wanted to say the thing that was hovering in the room. If an object were designed to conceal its most critical behavior, this alignment would be ideal. But in science, implication is not evidence. So we waited for the last piece of the puzzle, the object's reappearance. The morning the telescopes regained visibility, every system was aligned to a single coordinate. If the object had changed course, even slightly, it would confirm the most extreme interpretations. If it re-emerged exactly where gravity predicted, the entire atmosphere of speculation would collapse in a single breath. The first detection came from Pan-STARRS, faint but present. The follow-up from Hubble confirmed it. The object was exactly where it should be. No deviation, no unexpected motion, no evidence of thrust or maneuver, a natural path. For a brief moment the tension dissipated. It was as if the scientific community exhaled in unison. The object had remained loyal to the predictions. It behaved like a rock, a bizarre rock, yes, but one governed by normal physics. Publicly, the mystery was resolved. The more dramatic theories were set aside. Even internally, the tone shifted from cautious suspicion to quiet relief. Nature, it seemed, had chosen the simpler explanation. But beneath that relief, a single thread remained loose, a question so small it almost escaped notice. Had the object truly behaved exactly as expected, or had we simply not looked closely enough yet? The final analysis, the one still waiting in unprocessed data logs, held the answer. And when that analysis reached the desk of a young researcher weeks later, the entire narrative would shift again. Because what she found didn't contradict the natural trajectory, it contradicted the physics behind it. And once that contradiction surfaced, everything we thought we had resolved would unravel all over again. When the object reappeared exactly where gravity predicted, Part 3 ended with a sense of relief, or perhaps something closer to denial. For a while, we all accepted the simplest explanation. 3I. Atlas was just an extraordinarily strange rock, but that certainty collapsed the moment the post-perihelion data reached the hands of a single analyst who wasn't looking for anomalies at all. Her task was routine: compare the object's mass and reflectivity before and after its pass behind the sun. Within minutes, she found the contradiction that changed everything. By all measurements, 3I Atlas was lighter now, not dramatically but measurably. A natural comet would lose mass as heat drove off gas and dust. So at first, her finding made perfect sense, but then she ran the orbital calculation. If a comet sheds material unevenly, the process acts like a series of tiny thrusters. It should nudge the comet off its predicted path. It's messy, chaotic, and unavoidable in every known cometary model. Yet 3I Atlas had not shifted at all. Its path was still perfect. Not slightly off, not subtly curved, not mathematically perturbed. Perfect. The analyst recalculated, then recalculated again, and again. Each result delivered the same impossible conclusion. The object had lost mass without experiencing a single measurable non-gravitational force. The only way this could happen was if the mass were released symmetrically, expelled in every direction at once, with such exquisite balance that every push canceled its opposite. A natural comet cannot do this. Nature is clumsy, chaotic, Imperfect, but this release had been engineered with the precision of a deliberate maneuver. The implication spread quietly across the internal channels at JPL. If 3i Atlas did not perform a maneuver as a whole, perhaps it didn't need to. Perhaps its outer shell, the rock we observed, had been merely the carrier. And then the more troubling question emerged. If the mass it shed wasn't debris, what was it? Some of the fragments recorded in the final spectroscopy were metallic. Others bore the same anomalous nickel-rich composition detected earlier. The numbers were small, too small for telescopes to track individually, but they were numerous enough to account for the object's missing mass. A new simulation was opened. If even a portion of that released material had its own propulsion, small, efficient, unobservable against the solar glare, it could execute a maneuver independent of the main body. It could alter course unnoticed, and the main object, now lighter, would continue along the natural trajectory, innocent and predictable. A perfect decoy. That idea spread through the analysts' chat logs like a whispered rumor no one wanted to put in writing. A Trojan horse. A delivery system disguised as a comet. The real payload, smaller, faster, and far more maneuverable, released at the precise moment when no telescope on Earth could see it. If the idea were wrong, the fragments would disperse harmlessly. If the idea were right, they could now be anywhere, following a new trajectory invisible to us. The analysts tested a hypothesis. If the fragments used even minimal thrust during the blackout, where would they go? The simulation produced a single clean trajectory. Not toward Earth, not toward the Sun, toward Jupiter. Arrival window, March 2026. The room fell silent as the numbers stabilized. The implications were immediate. The decoy, the main nucleus, had played its part perfectly. It left no indication of artificial behavior. But the fragments? They could be probes, observers, instruments, anything. The next logical question was the most unsettling. Why Jupiter? There are scientific reasons to study the gas giant, its magnetosphere, its moons, its radiation belts. But the trajectory was too narrow, too deliberate. It aimed not broadly at Jupiter's region, but at a defined corridor near its outermost moons. Internally, the decision was swift. You cannot track objects designed to avoid detection, but you can monitor their destination. NASA and ESA quietly redirected a suite of observatories. Publicly, the justification was harmless. Calibration tests, atmospheric monitoring, magnetic field surveys. Privately, every telescope was watching for a flicker, a pulse, a thermal spike, anything. And still, an older anomaly resurfaced. The eighth one few had dared to revisit. The origin point. 3i Atlas had entered our system from the same region of sky associated with the 1977 WOW signal, within 9 degrees. The match seemed symbolic at first, a coincidence borrowed from history. But now, with the possibility of probes heading toward Jupiter, the coincidence no longer felt incidental. A new theory took shape. A radical one. What if the WOW signal wasn't a distant broadcast from hundreds of light years away? What if it was local? What if it was a dormant beacon already within our solar system? One that transmitted a status report in 1977 and fell silent again? If so, then 3i Atlas wasn't a visitor responding to us. It was a response to something else. A delivery sent from far away to rendezvous with an asset that had been here long before we ever looked up at the stars. For now it remains speculation. Careful, restrained, uneasy speculation. But as the days move toward March 2026, one truth is becoming harder to ignore. If the swarm exists, and if it is heading to Jupiter, then whatever waits for it there may reveal a history of our solar system we were never meant to know. And that possibility is no longer hypothetical. It is approaching on a clock we cannot stop. When Part 4 ended, we were left with a possibility that refused to disappear. The fragments released at perihelion might not have been debris at all, but a hidden payload on a quiet trajectory toward Jupiter. And as the weeks passed, that possibility became harder to dismiss. By the beginning of 2026, the internal team monitoring the Jovian system had grown from a handful of analysts to an unofficial, classified network spanning NASA, ESA, and a few independent observatories whose directors agreed to reroute their instruments without asking too many questions. Officially, all of them were studying Jupiter's atmospheric dynamics. Unofficially, they were watching for something that shouldn't exist. The main body of 3i Atlas continued drifting outward on its hyperbolic path, exactly as predicted, a harmless, silent comet-like object fading back into interstellar space. But nobody in the private channels cared about the decoy anymore. Every calculation, every sleepless shift, every recalibrated sensor was focused on what might already be traveling ahead of it, a set of small metallic, untracked objects moving toward Jupiter's outer moons. The question that haunted everyone in those quiet rooms was simple. If the swarm cannot be observed directly, can its destination be observed instead? The Jovian system is full of electromagnetic turbulence. Its magnetic field is immense, its radiation belts violent and unpredictable. This chaos became an advantage. Any anomaly inside that noise would stand out precisely because the baseline is so well understood. So the team decided to monitor the moons, Europa, Ganymede, Callisto, each one capable of hosting geological, magnetic, or thermal activity that could reveal an external influence. For weeks, nothing happened. Every night the sensors returned the same familiar patterns. Jupiter remained Jupiter, vast, restless, and indifferent. The silence almost felt mocking. Some began to doubt the entire premise. Maybe the fragments hadn't gone anywhere. Maybe they had vaporized in the heat of perihelion. Maybe the symmetry calculation had contained some unnoticed error. Even I found myself hoping for a mistake. But in science, hope is meaningless. Only data matters. On a late February night, the data changed. It was subtle, a faint, structured radio pulse buried beneath Jupiter's magnetic noise. At first, the algorithm flagged it as statistical interference, but then the pattern repeated, and repeated again. 72 seconds long. Identical spacing. Identical modulation. A mathematical structure impossible to attribute to geological processes or atmospheric lightning. The signal wasn't coming from Jupiter's swirling clouds. It wasn't coming from deep within its magnetosphere. It was coming from the cold, shadowed surface of Callisto, the outermost of the three large Galilean moons. The room fell silent as the pattern stabilized. Prime number harmonics. Narrow band concentration. A timing signature that matched only one historical record. The 1977 WOW signal. For decades, the WOW signal had been assumed to originate from deep space, perhaps from a distant star in Sagittarius. But now the coordinates, the period, the structure, and the amplitude painted a different picture entirely. The signal was not echoing from hundreds of light years away. It was rising from a silent frozen moon orbiting within our own system. The implications were immediate and overwhelming. If the WOW signal came from Callisto, then something on that moon had been active in 1977. Something dormant since then. And something that had now awakened, precisely within the predicted arrival window of the swarm. The team pieced the hypothesis together with an almost uncomfortable clarity. The object we called 3I Atlas was not an explorer. It was a courier, a delivery system entering our system to resupply, repair, or reawaken an outpost that had been here long before we were capable of detecting it. The main body, the visible nucleus, was the decoy. The fragments, the metallic symmetrical remnants, were the mission, and Callisto was their destination. Even now, the telescopes cannot detect the swarm directly. Their size and reflectivity make them effectively invisible. But the signal, the structured 72-second pulse, is proof enough that something on Callisto has changed state. Something is active. Something is responding. Some analysts privately suggested the swarm might already be on the surface or beneath it. Others speculated that the beacon had been waiting for a trigger, a handshake from the arriving probes. A few, more cautious, asked whether the WOW signal had ever been intended for us at all. Perhaps it had been a message from one machine to another. And the most difficult question, the one that hangs over every conversation, is the simplest. If an intelligence has maintained an outpost in our solar system for eons, why has it remained silent? For now, there is no answer. Only the quiet certainty that the Jovian system is no longer just a scientific target, it is a site of active observation. The story of 3I Atlas ends here, but the real narrative does not. Because every new cycle of the Callisto signal reminds us of something we can no longer ignore. We are not witnessing a first contact. We are witnessing a continuation. Whatever waits in the shadows of Jupiter's outer moon has been here longer than our species has been able to look skyward. And now, for the first time, it is no longer silent. What happens next is something no model, gravitational or otherwise, can predict.